Hi everyone, and welcome back to the video for 3.3. We're going to look more at truth tables. This time we're going to focus on conditional statements, which are if-then, and biconditional statements, which are if and only if statements. So in my first example here, I have a conditional statement which says, if you get an A, then I will buy you a car. So we're going to develop a truth table for the conditional statement. So if we look at it like this, so if you recall, we use the letters P and Q. You can use any letters you want, but we typically use P and Q. So P is going to be the first part of the statement after the word if. So P is just going to say you get an A. And Q is going to be the part after the word then. If you'll remember, that's called the consequent. So Q will be, I will buy you a car. So when we develop a truth table, remember we have two columns for P and Q because there's four cases. Both could be true. One of them could be true and the other false, or they both could be false. If I want to look at the conclusion for if P then Q, which we would write P and then the arrow pointing to the right Q, think of this as fulfilling a deal. So if you get an A, then I will buy you a car. That's a true statement. I followed through on my deal and bought you a car because you got an A. In the second case, you get an A, but it's false that I will buy you a car. So I didn't fulfill on my promise of buying you a car. So therefore, that's false. If P then Q is false. In the third case, you didn't get an A. However, I will buy you a car. I still fulfilled on my promise of buying you a car. So that's true. And if you get an A, then I will buy you a car. Again, in this case, I did not break my promise of buying you a car because you didn't get an A. So that would also be true. So one of the things you want to remember here is assume the statement is true except when I've broken my promise to you. And again, you didn't get an A, and I didn't buy you a car. So I did fulfill my promise, which is why the last one is true. So one other way to remember this is that if P then Q is true in every case except when P is a true statement and Q is a false statement. Let's try to construct a truth table for the statement, if not P, then not Q. So I need a column for P and Q as usual. So we have true, 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 false, false, true, false, false. And now I need a column for not P, so I'm going to negate the P column, so they just become opposite. And I need a not Q, so I'm going to negate the Q column, again, just making them opposite. And now I have everything I need. I have if not P, then not Q. So remember, if we look back at our note, it's true in every case except when P is a true statement and Q is a false statement. So when I look at this, here in this row, P is a true statement and Q comes out to be a false statement. Think of it again as not fulfilling the promise. So it's like true, you got an A. False, I didn't buy you a car. So false and false would be you didn't get an A and I didn't buy you a car. That's true. In the second case, you didn't get an A, I bought you a car. I fulfilled my promise. In the third case, you got an A, I didn't buy you a car. That's false. And in the last case, both are true. You earned an A and I bought you a car. So I fulfilled my promise. Try pausing the video and constructing a truth table for the next example. So if you noticed in this next one, we have 3 letters, P, Q, and R. So that increases the number of cases that we could have. How many cases do you think we will end up with when we have 3 letters? So if you think about it, when we have 1 letter, P, there's 2 cases. It's either true or false. When we have 2 letters, P and Q, there's 4 cases. When you have 3 letters, P, Q, and R, there's 8 cases. So when we make our columns, we need to have a column for P, Q, and R. So we're going to rewrite P like we're used to it. It could be true, 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 and then false, 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 false. With Q, we alternate, so it's true, false, true, false, true, false, true, false. And with R, we're going to have double trues and double falses. So true, true, false, false, and then repeat. True, true, false, false. Now you have every combination that can occur. So if you look at the problem, we have a not Q. So I need a not Q column. So you're going to take the Q column and negate it. Now I'm going to work with what's in the parentheses. So I have everything I need to do that. This is not Q and R. So remember, and means both of them have to be true in order for the conclusion to be true. And the only instance I see that are in those 2 rows there. So all the others are going to be false. And then for the last one, I have everything I need now. So now for if then, remember if we go back and look at our note, it's true in every case except when P is true and Q is false. So we're looking at the P column when it's true, and then we're going to focus on this column. And if we have true in the P column and false in the not Q and R column, it's going to be false. So here I have a true and a false, so that's a false. I have a true and a true, so that's a true. I have a true and a false, so that is false. I have true and false again, so it's false. And then I have a false and a false, so that's true. And a false and a true, which is also true. False and false is true, and false, false is true. Now let's look at biconditionals. So biconditionals are if and only if. And in this case, we use the double arrow. So this says P if and only if Q. Which implies that if P then Q and if Q then P. So remember, it has to work both ways. Symbolically, this is how we would write it. So if P then Q and if Q then P. We're going to construct a truth table to prove this. So I have two letters, P and Q, so we know that that's going to be the following. And now I'm going to look at if P, then Q. So remember, it's going to be false if the conclusion is false and the original statement was true. So here it's true, true. Here it's true, false, which means I didn't keep up with my end of the deal. That's false. False, true is true, and false is true. Again, think back to you didn't get an A, so you don't get a car. Now I'm going to look at if Q, then P. So now you're going to reverse the columns. So look at Q first, then look at P. So true, true is true. Then I have false, true, which is true. But in the third line, I have true, false, which is false. I didn't keep up with my end of the deal. And the last one stays false, false, and the conclusion is true. So now if I put both of those columns together, if P, then Q, and if Q, then P, remember and means both need to occur. So I'm going to look at these two columns here, and remember that I need both of them to occur because that's what and implies. And means that both need to be true for a conclusion to be true. So now if I go through and look at the first row, it's true, true. So my conclusion's true. These are both false because they're not the same. And the last one's true. So as you can see here, if you look at this first row and this last row, they're true, which makes sense. It's telling us that if P occurs, then Q occurs is true, and if Q occurs, then P occurs is true. And the last statement is telling us that if you reverse it, if Q then P and if P then Q, both are true as well. But the middle two don't work because one of those statements is false, which means the other can't work. Try pausing the video and see if you can construct a truth table for this statement. Again, we have P, Q, and R. So I'm going to have 3 columns and I'm going to have 8 cases. Now I need to look at my statement. I have not P, so I need to take the P column and negate it. I also have not Q, so I need to take the Q column and negate that. Inside parentheses, I have not Q. If not Q, then R. So I'm going to look at my Q column, and I'm going to look at that first, and then my R column. So remember, if the Q column is true, if the not Q column is true, and the R column is false, then it's false. So I'm going to write if not Q, then R. So again, the not Q column, if it's true, and R is false, I didn't keep up with my end of the deal, so therefore it's false. So this is false, true, that's true. True, true is true. False, false is true. True, false, I didn't keep up with my deal, that's false. False, true is true. True, true is true. False, false is true. And again, I have true, false, I didn't keep up with my end of the deal, so that is false. Now I have every piece of the statement in my table. I'm going to put it together. So I need not P, and then I need not, if not Q, then R. So not P, if and only if, not Q, if not Q, then R. So remember, for a biconditional, both statements have to be true for the conclusion to be true. So I have false true, which is false. False true again, false. False. And now I have false and false. As long as they're the same, it's true. True, true. And then true, false. And this is my answer column. So remember, if it's a biconditional, both have to be the same answer. So in this case, since I had a false and a false, it comes out true. And since I have a true and a true, it comes out true. Let's look at an application. Take a second to read the problem. Feel free to pause, and then we'll do this together. The graph shows the United States market share for various brands of cell phones in 2018. Use the data presented in the graph to determine the truth value of the following compound statement. If Apple has 39% of the US market share and Samsung has 36% of the US market share, then LG has 17% of the US market share. So we're going to let the first part of the sentence be P, which is Apple has 39% of the US market share. The second part will be Samsung has 36% of the US market share. And R will be the third part, which is LG has 17% of the US market share. Now let's write this in symbols. So in this first part, it says if, so we have a conditional statement. Apple has 39% of US market share, and then sorry, wrong red letter there, and Samsung has 36% of the US market share. Then we have our then, LG has 70% of the US market share. So here, if I want to write this, I have an if then. So I know that I'm going to have a right arrow. So this is going to be if Apple and Samsung, then LG. So we can solve this without actually making a truth table. By looking at the circle graph, does Apple have 39% of the market share? They do. So P is true. And Samsung, do they have 36% of the US market share? They don't. They only have 25, so that would be false. Does LG have 17%? They do, so that's true. So remember, you have an if-then statement here. True and false. In order for an and to be true, both have to be true. So because it's an and one's true and one's false, it's false. So this says, if false, then true. Are you keeping up with your end of the deal? You are, because the conclusion's true. So therefore, this is true. The last thing we're going to talk about in this section are three topics called self-contradiction, tautology, and implication. So in self-contradiction, we have a compound statement that's always false. Think about what the prefix contra means, or even the word contradiction. Contra means against, so it means against what someone's saying, so it's false. A tautology is always true. So an easy way to remember that is T for tautology, T for true. And an implication is a conditional statement that is a tautology, so it's always true. If you think about when people use the word imply, so this implies, something else. You're assuming whatever it's implying is true. So an implication is a conditional statement that is a tautology, so it's a compound statement that's always true. Let's construct a truth table for the statement. So this, remember, says P if and only if Q, which implies if P then Q and if Q then P. And then we have and the next part states P if and only if not Q. So to construct a truth table, we have P and Q, so we know that that's going to be true, 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 false, false, true, false, false. I have a not Q, so I'm going to take Q and negate it. The first part says P if and only if Q. So remember, for if and only if, both have to be the same. So we're looking at P if and only if Q. In that first line, I have true, true, so it's true. And then in the last line, I have false, false, which is true. The other two have to be false. In the next parentheses, I have P if and only if not Q. So now I'm going to focus on P and not Q. Again, as long as they're both the same truth value, the conclusion's true. So I have true, false, that's false. True, true is true. False, false is true. False, true is false. And now I'm going to take both of these columns and I'm going to combine them for the last one. So P if and only if Q and P if and only if not Q. So remember, for and, it needs to be, both have to be true in order for the conclusion to be true. So the first line, I have true, false, we know that's false. Here I have false and true, which is false. False and true again is false. True and false is false. Here's my conclusion column. What type of statement do you have here? Is it a self-contradiction, a tautology, or an implication, and why? This is a self-contradiction. It's a logically false statement because all of our conclusions were false. If we had all true conclusions, we would have a tautology. That is the end of section 3.3, which brings us to the last lecture of this week. I hope you all are having a great week and you've started on your homework. Please begin on homework 3.3. And if you have any questions, please reach out to me. I hope you all enjoy the rest of your day.